Today we're going to be looking into a topic that will not be in our final test, but will be in the remaining ALEKS item, which we have in section 8.3. But I'm going to look briefly into this topic, and then we'll cover some of the bases regarding the fourth and final test. And just looking at what we have concerning partial fraction decomposition. Now, back in chapter R, we looked at combining fractions that, say, had unlike denominators, and we did the stuff like finding the least common denominator, and then we looked at adding the fractions after writing in terms of the least common denominator and putting together as a single term. With partial fraction decomposition, we're looking at it going in the other direction, where you're looking at essentially what difference or what fractions will be such their sum or difference will form the given ratio. And for what we have as a sample, we have 6 all over x squared plus 4x plus 3. And this ratio can be made up by two particular fractions. And with the partial fraction decomposition, so we have with this ratio, in terms of partial fraction decomposition, we're going to have the denominators of what will be referred to as partial fractions to consist of the factors that make up what we have with x squared plus 4x plus 3. And so looking at initiating the process, so we have with 6 over x squared plus 4x plus 3. And if I write the trinomial in the denominator in its factored form, so we have for x squared plus 4x plus 3, that'll be factorable to x plus 3 times x plus 1. And we have with the factors, we're going to have partial fractions. One that's going to have the denominator of x plus 3, and the other which will have x plus 1 at the bottom. So we have just setting the stage here. And it doesn't matter which denominator comes first, but we'll say we have x plus 3. So we have a over x plus 3 plus b all over x plus 1. And we're looking at trying to solve for a and b. So we have for this setup, now so we have the factored form of the overall fraction. We have 6 over x plus 3 times x plus 1. Again, we have equal to a over x plus 3 plus b over x plus 1. And what we're going to do is establish a linear equation such that we will be able to solve for a and b. And what I mean by this, I'm going to clear away the fractions so I can multiply all the expressions out by both x plus 3 and x plus 1. And looking at what we have in the formation. So for what we have now, so you have 6 all over x plus 3 times x plus 1. And if I multiply this ratio by the least common denominator, so we have x plus 3 and x plus 1 will completely cancel. And looking at applying the same treatment for a over x plus 3 and b over x plus 1. So with a over x plus 3, again multiplying by both x plus 3 and x plus 1. Now for a, we're going to have x plus 3 to cancel out, but you're going to have a to ultimately be distributed over the quantity of x plus 1. Now for b, you're going to have the reverse situation. So for what we have here, x plus 1 is going to cancel, and you have x plus 3 to remain. So setting up what we have now, left hand side, okay, we'll have it 6, and we have is equal to, and we'll have a times the quantity of x plus 1. And as for b, okay, this will be times the quantity of x plus 3. And looking at what we have right now, okay, so you have a and b, okay, those are two unknowns, and we're trying to discover, okay, just what the corresponding values will be in this partial fraction decomposition, and creating a pathway to solving for either a or b first. What we can do, if we're looking at, let's say if we want to determine what the value of a is first of all, okay, if you notice, okay, I can eliminate the presence of b, where it is multiplied by the quantity of x plus 3, and think of zeroing b out. Okay, so if I have like x plus 3 is equal to 0, I can set x to -3. And applying -3 to x in this equation. Okay, so starting out, we have that 6 is equal to a times the quantity of what is going to be -3 plus 1, plus b times the quantity of -3 plus 3. If you notice, okay, -3 plus 3 will zero out. Okay, so the presence of b is going to be eliminated. Okay, so we've got the left hand side is going to be at 6, and we have a times -3 plus 1. -3 plus 1 is going to be at -2. So 6 is equal to -2a. So for what we're going to have in this case, right, so we have 6 over -2 is -3. -2a over -2 is going to be a. And so we're going to have that the value of a is -3. Right, so I have a. Now turning the tables and eliminating the presence of a in order to solve for b. Okay, alright, so I eliminated b first of all, setting x plus 3 to 0. Now looking at solving for b, I can eliminate the presence of a, so envisioning setting x plus 1 equal to 0, and we'll have that x is equal to -1. Again, same equation, but -1 is now going to be plugged in for x. So we're going to have that 6 is equal to a times the quantity of -1 plus 1. Again, this is going to be zeroed out. And we have plus b times the quantity of -1 plus 3. So we have on the left, okay, so we still have 6, and b we have times quantity -1 plus 3, so this will be 2b. And we have a division by 2. Then we have that 3 is equal to b. And just switching the order, so declaring the value of b. So we have that b is equal to 3. And just looking at what we're going to have for the partial fractions. Again, so we have a at -3, b at 3. And again, we have with the partial fraction setup. Okay, so we had a over x plus 3 plus b all over x plus 1. And now we have, in the case of filling in terms of the fractions, with these factors for individual denominators, okay, that will add up to 6 over x squared plus 4x plus 3. It's going to turn out that, okay, with a at negative 3 and b at 3, we're going to come out to negative 3 over x plus 3 plus 3 all over x plus 1. And that will be the result in this case. All right. Now, for what we have as another situation, as a ratio whereupon we can perform partial fraction decomposition. Okay, say if I have 5x minus 2 all over x squared minus 4. Okay, so the denominator, okay, we're going to have a difference of squares. Okay, so we have upon factoring, okay, so 5x minus 2 or x squared minus 4. So this will factor out to x plus 2 and x minus 2. And for the partial fractions, again, whichever denominator comes first, it does not matter. It could be x minus 2 or x plus 2. So we have one numerator over x plus 2 and 1 over x minus 2. And we have in this setup, okay, we're looking at solving for a and b. So I can clear out the fractions, okay, this time multiplying everything out by the factors of x squared minus 4 looking at clearing out the fractions. Okay, so first of all, okay, we have the elimination of the denominators. Let's multiply by both x plus 2 and x minus 2. Okay, so I have x plus 2 and x minus 2 to go out. And for what we have on the right hand side, okay, you're going to eliminate one part and multiply by the other. Okay, so you have for a over x plus 2. Once again, multiplying by the factors. So now we'll have x plus 2 eliminated, and a is going to be distributed all over the quantity of x minus 2, and for b, it'll be the other way around. Okay, so I have x minus 2 to go out. All right, and now just setting the stage, okay, transitioning from an equation between fractions, okay, to where we're going to have the coefficients in direct terms. So we have on the left, okay, x plus 2 and x minus 2 go out completely. So left hand side, okay, we'll have it 5x minus 2. And for what we have to the right, now for a, okay, we have x plus 2 to go out, and we have distribution over the quantity of x minus 2. Okay, as for b, okay, which was over x minus 2. Okay, x minus 2 cancels out, and we'll have b to be distributed over the quantity of x plus 2. All right, so we have, just like in the first example, we have two unknowns with a and b, and we can eliminate the presence of one and solve for the other. Okay, say if I were to solve for a first, again, I can eliminate the presence of b if I take the factor alongside it and set to 0. So if I eliminate b, I can find the value of x such that x plus 2 is equal to 0. In this case, we have that x is negative 2. So filling in negative 2 for x, and notice I have this time x on both sides of the equation. Okay, so b is going to go out, and working with what we have. Okay, so you have 5 times negative 2 is negative 10. Take away 2, and then we have for a, we're going to have negative 2 minus 2 is negative 4. Now we have negative 10 minus 2 is going to be negative 12. And we have that negative 12 is equal to negative 4a. And we have with division by negative 4. Okay, so you have negative 12 over negative 4 is going to be 3. So you got 3 is equal to a. Okay. And conversely, again, we'll have the a is equal to 3. Okay. So you have the solution to a, and then sort of switching places in terms of what to eliminate and what to solve for. Okay, so for solving for b, I can eliminate a and setting x minus 2 to 0, and we'll have that x is equal to 2. And we have in the equation going back. So we have 5 times 2 minus 2. Have is equal to, and we have a times the quantity of 2 minus 2 plus b times, okay, the quantity of 2 plus 2. Okay, so a is going to go out, working with what we have now. So 5 times 2 is positive 10. We have minus 2. For b, we have 2 plus 2 is 4. And the right hand term, okay, we have at 4b. So we have 10 minus 2 is 8. And we have that 8 is equal to 4b. And we have with division by 4. Okay, so it's going to turn out that for the value in b, okay, that is going to end up at 2. Right. So we have with a at 3 and b at 2. Again, we have with the setup with the partial fractions. Okay, now we have our values for a and b, and so filling in, it's going to turn out that for 5x minus 2 all over x squared minus 4, we have for the partial fractions. Okay, so you have a is at 3, b is at 2. So 5x minus 2 all over x squared minus 4 is going to be equal to 3 over x plus 2 all over x minus 2. Okay. Now, let's say if there's a situation where we might have more than just two distinct denominators. In the partial fraction decomposition, I'll have with this one more case. Now, let's say that if we have, for the ratio, okay, if I have 3x squared plus 4x plus 2 is all over x cubed plus 2x squared plus x. And setting things up, okay, and establishing at least the general case for the partial fractions. Okay, so initiating. Okay, so if you notice in the denominator, okay, so I have the terms of x cubed, 2x squared, and x. So all of these are variable terms. So I can start out by factoring out x. Okay, so I have x times, okay, the quantity. Okay, so I have x squared plus 2x plus 1. And with x squared plus 2x plus 1, okay, I can factor this, and this is a case of what we have with the squared trinomial. So for x squared plus 2x plus 1, you have x plus 1 times itself. So you can say we have x plus 1 raised to the second. Right. And now, for the partial fractions, what's going to happen here is that we have x as its own denominator. Now for x plus 1, okay, notice that this is squared. And this is going to be what is referred to as a repeating linear factor. Okay. And what's going to happen here is that you're going to start in first order with a linear factor that repeats. So you have like b over x plus 1. And you'll keep applying until we get to the original degree, or the display degree of the repeating linear factor. So we need only go so high as x plus 1 to the second. And we pause right here. Okay, so about this case, for the partial fraction decomposition initiating. And now, let me mention, okay, so with that too, okay, we have again what is a case of repeating linear factor. Now I'll just mention, okay, let me give just an example, okay, like in terms of how I got to x plus 1 and the square of x plus 1. So we have like a case of partial fraction decomposition setup. Like if I had something like 2x plus 3 and say we have all over x minus 1 to the third. Like x minus 1 will be a repeating linear factor, and notice we have this is going to be a third order. So if I had to apply the general case, so we'll start from the first order. So we have a over x minus 1. And we'll progress, like for b, we have all over x minus 1 to the second. Now for C, okay, we have x minus 1 raised to the third. So anytime you have a repeating linear factor, again, you start from the first degree, you just add a fraction to the second, and so on until you get to the original degree. All right. Now, for what we have for this particular case, and going back, okay, so we've got a over x, b over x plus 1, and c all over x plus 1 to the second. Now, if you notice, okay, we're going to clear out the fractions. And what I'm going to do here is I'm going to multiply everything out by x and the square of x plus 1, which happens to be the least common denominator. So if I multiply by x and the square of x plus 1, okay, so we have a bit of history to repeat, like in terms of eliminating the denominators. Okay. And so for what we have on the left-hand side, okay, so here for the first ratio, so I'm multiplying by x and the square of x plus 1. So we have a complete elimination. Now for what we have with the terms on the right. Okay, so you have with a over x. Let's create a bit of room here. So I have with a over x, okay, so multiplying this by x, and the square of x plus 1. Okay, now we're going to have x is going to be eliminated, but you have the square of x plus 1 to remain. So I'm just going to go ahead and put down what we have so far. Left hand side, okay, we're going to have 3x squared plus 4x plus 1 is equal to, we've got a times the quantity of x plus 1, where x plus 1 is going to be squared. Now for what we have in the case of b over x plus 1, this is perhaps the trickiest one among the trio. Okay. Now we have again multiplying by both x and the square of x plus 1. Okay. Now, we notice to have x plus 1 is a first degree, and we're multiplying by x plus 1 of second order. So for what we're going to have here now, x plus 1, the denominator is going to cancel, but we're still going to have an x plus 1 of first order to remain. So we're going to have, in the case of b, we have b times x times the quantity of x plus 1. And then finally for c, over the square of x plus 1. So multiplying by x and the square of x plus 1. Okay, so we have x plus 1 squared. This will go out, and c is going to be distributed. We're just going to multiply x. Okay, so this is going to be our setup equation. And now, looking at what we have in the process. Okay, notice, okay, we have three unknowns, okay, with a, b, and c. And there are only two factors that we have in x, one being x itself and the other x plus 1. And I can create a pathway to solving for a, b, and c. First of all, I can solve for a, again, because we have with x alongside b as well as c. Okay, I can set x to 0. So if I set x to 0, so I have 3 times the square of 0. That's 4 times 0 plus 1. And on the right, just have 0 plus 1 squared. And for the b and the c terms, now we've got b times 0 times 0 plus 1. So already multiplying by 0. Okay, the b term is going to go out, and the same thing is going to happen for c. And so for what we have in the process, okay, so you got 3 times 0 squared is 0, 4 times 0 is 0. Now we got 1. 0 plus 1 is 1. 1 squared is 1. So you have that 1 is equal to a. So we have that a is equal to 1. Right. So I set x itself to 0. And with the other variable factor at x plus 1, if I set this equal to 0, and we have that x is equal to negative 1. I'm going back to the equation case, so we got 3 times the square of negative 1 is 4 times negative 1, followed by the addition of 1 to the right. So I have 8 times, okay, the square of negative 1 plus 1, so that is going to go to 0. We've got b times x at negative 1. However, with x plus 1, and with x at negative 1, we've got negative 1 plus 1 also at 0, so b is going to go out. And we have plus c times negative 1. And looking at what we have now, okay, so we got negative 1 squared is going to be 1. So we have 3 times 1. 4 times negative 1 is negative 4. Plus 1. Again, with a and b out of the picture, we got on the right, we have negative c. Yes, let me double check for x. Ah, 2. That might make a little bit of a difference. Thank you. Okay, so we have that a is equal to 2, okay, and just fixing what we have here. There we go. All right. Right hand side is still going to be the same. Okay, so we got negative 1 squared is 1, 3 times 1 is 3, 4 times negative 1 is negative 4, and we've got plus 2. And we have is equal to negative c, 3 minus 4. Okay, that is negative 1 plus 2 is positive 1. So the 1 is equal to negative c. And changing the sign at both ends. Okay, so we're going to have that c is equal to negative 1. All right, so we got a, and we got c, Now we need to determine, okay, just what b is. And tell you what, just create a little bit of visual space. Okay, so we're going back to this equation, and I have used up the zeros of 0 and -1. Now what I can do is choose any value for x and following through. And generally, I like to keep the absolute value as small as possible and still be able to work with an integer. So I'll just choose, let's say for the x value, I'll just have this at x is equal to 1. You can choose any other value that has not already been selected or worked out. Okay, so if I were to choose x is equal to 1, and going to this equation, so 3x squared, so 3 times the square of 1 plus 4 times 1, plus 2, and a we've already determined. I'll get to that in just a moment. Okay, so I have a times 1 plus 1 squared. Got b times 1 times quantity of 1 plus 1 plus c times 1. And so we got 1 squared is 1, so we have 3 plus 4 plus 2. And got 1 plus 1 is 2. 2 squared is 4, so we have 4a. 1 plus 1 is 2 times 1 times b, so we got 4a plus 2b. We got c times 1, so we have c. Now we got 3 plus 4 plus 2 is going to be 9. Okay, now we have a at 2. And b we're looking at solving for. And c we have at -1. And we're going to have 4 times 2 is 8. Take away 1. Okay, so I have that 9 is equal to 7 plus 2b. And taking 7 away from both sides. Okay, so we have that 2 is equal to 2b, and with division by 2, okay, we're going to have that the value of b comes out to 1. Okay, quite a bit of work in this one. Okay, so we have a at 2, b at 1, and c at -1. And for what we have in the case of the spread here, okay, so looking at what we have now, okay, so a is at 2, and b is at 1, and for c over the square of x plus 1, now c we have at -1, and so I just write this in terms of subtracting. Okay, so we got 2 over x plus 1 over x plus 1 minus 1 all over the square of x plus 1. Okay, so those would be your partial fractions, 2 that are positive and 1 which is negative. Okay, and now, so this is what we have for the case of partial fraction decomposition.